Dad, what's the future gonna look like?
Hey everyone, I'm Jim Martz. And today I'm here representing Vast Space. Want to throw a quick slide up here just of some of the background, because my background is very representative of a lot of the other people that we have at the company. You'll hear a little bit about what we're doing, but I think the only way that we can actually do the stuff that I'm going to tell you we're about to go do is from the team that we have. So I'm ex-SpaceX, JPL, Muon Space, and Zipline in my past. And something like, I want to say it's something like 25% of our total team is ex-SpaceX, of which it's over 30% is engineering and over 80% of our leadership is ex-SpaceX. So we're trying to do something that's really hard to go do, which is we want to go fly the world's first commercial space station.
We're at a point in history where we have never seen this much investment and activity in human spaceflight ever. We're on a trajectory that puts humans in space permanently.
The next big thing in space isn't just getting there. It's learning how to stay. With the International Space Station due to be retired in 2030, we believe it is up to us to solve for this future. That means building dedicated space stations for private and government astronauts, expanding access to low Earth orbit, and pushing even further, building human habitats for Mars.
It is very important, not just for the future of humanity, but the future of Earth, that we do our best to preserve it. Part of that story is actually getting humans off of Earth in a meaningful, long-term way.
No one has ever built a commercial space station. That changes with Haven 1. America's next space station and the world's first commercial space station.
It's hard to imagine how different this is going to be from the experience right now at the International Space Station.
In 2026, a crew of 4 will visit Haven 1 for 2 weeks, launching and docking aboard the proven SpaceX Dragon spacecraft.
It's important for humanity to get out into the stars. I think this is good not only economically, but just good for the human spirit. Humans need a frontier and something to explore.
We will be pioneering in-space manufacturing, unlocking new industries only possible in microgravity. Our unique strength lies in our strategy, building fast and keeping costs low with an unwavering focus on human safety.
We know we can do it, and we're doing it in an unprecedented time, probably 5 times faster and 5 times lower cost than anyone else has built a space station module.
Right now, there are nearly 1,000 experts at Vast who are designing, building, and preparing for Haven 1's first crewed mission in 2026.
We're doing something historic. This will be the first commercial space station. This is going to be a very big leap for humanity.
The timeline is definitely ambitious, but it should be ambitious. It must be ambitious.
There is no doubt in my mind that we are going to do this.
Join us in pioneering the next giant leap for humanity.
So luckily, the work that we've been doing and the team that we have makes my job easy because the story kind of tells itself and I don't have to do it. So, we are the crewed space systems company. You know, there's a lot of companies, some that you've heard here, you heard SpaceX yesterday, that are working on transportation on launch, figuring out how to get more mass to space for lower cost and more reliability. What we do with that then is really important, and when we have that extra mass to space, when we have access to space, what are we going to do with it? And so that's where Vast is really on the vision, is we envision a world where there are billions of people living in space. And that's quite a far future out right now, but we got to get started on that now. And so for us, we are the safe, fast, low cost, and reliable crewed space systems company. The first product that we're building is Haven 1. And so if you haven't been outside, please come after. Happy to show anyone around. But we're building a space station that's very much a minimum viable product. It's get up in space, learn how to keep people alive in space, make sure that we're doing everything that we can, and learn what's useful in space, what's not useful in space. There hasn't been an opportunity to have a commercial space station. It's only been through government national labs work, which means that there's a lot of other stuff that could happen in there that's going to evolve, and no one really knows exactly what that market's going to look like. So we're building this one here, and the idea with it is 2-week missions, crew of 4, transport via SpaceX Dragon, 3-year lifespan. So it's very much a minimum viable product, like I said. Get it up there. We'll be able to say, have a number of missions where people will go up for 2 weeks at a time, live in space, and come back down. And then once we've done a few of those, this space station will deorbit that, and we'll take those lessons learned and we'll incorporate it in the next one. And the idea that we want to get to is we want to be able to launch a module pretty much every year. And then we'll be able to build out a bigger and bigger station. The first station will just have one docking adapter on it, so we'll only be able to dock Crew Dragon to it. In the future, the modules will have double docking adapters. We'll be able to build out more capability and increase volume, bring new science, bring new capabilities, bring new manufacturing capabilities up to space. So set to launch in 2026, next year. You'll see a little bit later, we just finished the primary structure on it. This is the interior of it. Like I said, feel free to come outside and we'll show you around inside our mock-up of it out there. And one of the ways that we're being able to do this, VAST was only founded a few years ago, and we're saying we're going to launch a space station next year. So how do we go that fast? A lot of that is being able to leverage good partnerships, leverage good relationships in industry, and be able to leverage technology that exists. So we're using a proven Falcon 9 launch vehicle. We're using SpaceX Dragon, where we already have that mission with them booked, and we have our engineering teams work together on how are we going to be able to dock the two together. And then we also have the Starlink high-speed internet system. So we'll actually have laser communication systems on board so that we'll have always-on internet, which is going to be a game changer for what living in space has been like in the past. We also have a lab, and so one of the things that we really want to make sure is that this is not a hotel in space. This is definitely purpose-built to go expand, understand what capabilities will exist in space, especially for things like microgravity manufacturing, how things grow in space. How are we going to be able to go live in space and go deeper and further out, and what do we need to go learn about doing that? So inside the space station, we'll have this payload wall where you can see some of our partners on there already that have already signed up for us to go fly different payloads in space and be able to do different science experiments that the crews will interact with when they're up there. And a big part of what we're doing here is doing it all in-house. We partner wherever it makes sense. When there's good technology out there, there's a good partner that makes sense to use. Our propulsion systems comes from Impulse Space, Tom Mueller's company. But then other areas where we just need to do it ourselves has been like primary structure has been one of the big ones there. I think this is the first space station primary structure that's been built in America in the last 20 years. And we just finished the final weld on that structure, I think, last week. And then there's just a lot of pieces that have to go into this. So like I said, we're about 1,000 people company. To do a space station, you can't just do a small piece of it and be like, oh, cool, that's like, I'll do the rest of it later. Like, you have to keep people alive in space, and you have to do that from day one. So we've got solar panels, we've got a domed window, we've got our own custom hatch design, we've got control moment gyroscopes. This is a big technology that if you had to go out and procure this, we could not get these on the time frame that we needed them on. So ended up building them in-house. We have valves in-house. We have batteries that we've developed in-house that are fault tolerant to make sure that astronaut safety is paramount in the design of the batteries. We use the impulse systems for our thrusters and our deorbit capabilities. And so all that technology all has to come together for us to be able to do human spaceflight, which is going to be in 2026 to 2028. So what does a mission look like? A mission's going to look like, first off, when a crew signs up with us, they go through SpaceX training. So they're going to work with the Crew Dragon team, learn how Crew Dragon works, how they're going to fly with that, go through all the training on that. Then they'll go through launch. They'll go on station with us. They'll be able to spend time on station. it'll be a really nice environment to say, in the past there's been these like free flyer missions where there've only been a few days. This will really give the crew a lot more time to get on station, adjust, have more space, get used to the environment in space, be able to go perform tasks and operations, and be able to get real usefulness out of those missions. And then they'll come back down and do splashdown. And then the next thing that we've got going on after Haven 1, so like I said, minimum viable product, we're learning how to use it, is going to be Haven 2. And so NASA has a program that they're calling Commercial LEO Destinations. So the International Space Station right now, there's been a lot of news coverage over it. There's parts of it that are leaking. It's way past service life. The current NASA plan is that it needs to be deorbited, and that they've actually given SpaceX a contract to go build a deorbit vehicle to go deorbit the space station and put it down. NASA's current plan is that's around 2030. And so when they get to that, if nothing changes, and if VAST and others that are working on this do nothing, then if the ISS comes down, there will only be, the only space station that would be in orbit is the Chinese space station. And so it's really important for us as a country to be able to retain this capability. So that's one reason we're building Haven 1 is to go get that up, get that capability early. And then we're looking at Haven 2 as like the next iteration off of that. Take the lessons that we've learned from that, go incorporate them, and go build out a bigger space station that meets both NASA needs, commercial needs, and international partner needs as well. And this is generally just like kind of a glimpse at what the kind of interim steps look like. And a big part of our strategy is making sure that we're modular, scalable, and that we can respond to what the markets need. Space stations are a new market. We don't know exactly what that market's going to look like. And so we need to make sure that we have the capability and that we can react to it, and make sure that we can launch new modules, that we can outfit them with different capabilities, whether that's for science, whether that's for in-space manufacturing, whether that's for entertainment. There are a number of different things that we want to be able to do with this, but we'll keep building out a bigger space station and add more capability to it. As we add capability, it will also allow our crews to stay up there longer. We'll be able to build more recycling systems to be able to take bring the consumables that we bring up, such as water, food, carbon dioxide, scrubbers, all that stuff. As we add more capability and technology, those supplies will last longer and longer. The crews will be able to stay up there longer and longer. And then when you think about building a space station company, probably the first thing you launch should not be a space station. And so we're building what we call Haven Demo. I actually just flew in this morning because we just put this on the rocket. But it's about a 550 kilogram, so a little over 1,000-pound spacecraft, about yay big or so, that's just packed with all the technology that we need to go fly a space station. So it's got propulsion systems, it's got solar arrays and batteries, it's got custom avionics that we've designed that's fault tolerant, it's got guidance navigation sensors, it's got all the software systems that we've got, and then the other big thing that we're able to test is we want to put it up there and be able to get it in orbit and then prove out all the communication systems, show that we can talk from the ground up to it and vice versa. And we want to do all of that ahead of time before we go launch a space station. So this is going to be launching actually this year. And that's a pretty picture of what we just put on the rocket right there. This is just a few pictures of us last week shipping it down there. And then there's one more video on here of the primary structure.
VAST is building next-generation space stations to pioneer the future of long-term living and thriving in space. Starting with Haven 1, the world's first commercial space station. To achieve our vision, we begin with Haven Demo, an in-orbit testbed for critical space system technologies. Haven Demo has been fully integrated, and all major testing, including thermal vacuum, electromagnetic interference, radio frequency, and vibration, is complete. We've integrated key power and propulsion components, the solar array, batteries, and core avionics that will eventually fly on Haven 1. Haven Demo is in the final stages of verification and integration, getting ready to launch from Cape Canaveral, Florida. At our Mojave facility, the Haven 1 primary structure qualification article has successfully completed its rigorous testing campaign. Since January, we've subjected the article to 53 distinct load cases to simulate the launch environment and conducted over 200 pressure cycles to ensure its reliability and integrity for on-orbit operation. The Haven 1 flight primary structure has been fully welded through a series of critical manufacturing milestones. We first welded vertical sections creating barrels, which underwent non-destructive testing and evaluation. The completed structure is ready for pressure testing, with integration to follow. In the Haven 1 lab, advanced air filtration and life support systems will operate behind an intuitive user interface. Multiple payload lockers will house experiments from our lab partners, and the domed window will offer astronauts a breathtaking 180-degree view of Earth. At FAST headquarters, we've completed construction of a state-of-the-art mission control center equipped with a 1,500 square foot display wall and 24 operator stations. It will be used to monitor future missions, connecting operators to live spacecraft data and video feeds, and enable communication with the crew. From Haven demo to the final weld of the Haven 1 flight primary structure, our progress proves the effectiveness of our vertical integration and our team's speed, ambition, and innovation.
So yeah, I'll leave you with this of, VAST is investing about $1 billion to get ourselves up to the first space station up there and get the first crews up there. We are in the midst of a funding round right now. But yeah, I'd like to leave you guys with vision is billions of people living in space, and if you'd like to come out and see the space station, let me know, grab me, and I'll be happy to give you a tour.
The future is gonna be awesome.